Hi, I'm Gary Rubenstein, and this is the 14th video in a series where I take you from kindergarten through about 11th grade math, my thoughts on all the different topics as someone who's been teaching for 30 years and who's also a parent. So let's get into this 14th topic, which is using algebra to find intersection of two graphs and why we might want to do that. So here's an example. Here's two lines, a red line and a blue line. And those lines might represent something in the real world, like the cell phone example, how much money it costs if you use, where the X is like the number of minutes, and this is like how much money it costs. And we have these two competing plans, and we want to know under what conditions is it better to go with the blue plan than the red plan. And to do that, we'd want to know what is the intersection point. And in this example, we can kind of see where it is, but maybe it doesn't fall so nicely on the corner of one of those boxes. So what you do is you take, if you don't have the equations, you use techniques that I went over in previous videos to figure out what the equation is for these two lines. Then, that's in the graphing lines video, then you can use techniques from the systems of equations video to find the x and y values that make both of these equations true. Because this red line has a solution set, and every point on it, for example, 0, 1, is a point in the solution set because it's true that minus 0 plus 1 equals 1. But there's all these other points, infinite many of them actually, on the red line. There's also infinitely many points on the blue line, but there's only one point, in this case, that's on both lines, the intersection. And if we use techniques, I like to personally make it so one of these is positive and one's negative. So if I take that bottom equation and I multiply it through by -1, I get x minus 2y equals minus 6. Then if I add these two equations together, the minus x and x becomes 0x. Minus y plus negative 2y is negative y. And 1 plus -6 is -5. So y equals 5. And that is the y-coordinate of this point. To get the x-coordinate, you can take this y value and put it into either of these equations. I like to put it in that first one. And then we use the two-step algebra from an earlier video. And we end up with the coordinates of this intersection point. So there are times where these graphs might be meaningful. Like I said, it could be time and it could be money. And using algebra over here to find the intersection point, that intersection point might be meaningful to us. Like we say, okay, so it turns out that this is cell phones, that if I use 4 hours, of time, those two plans cost the same amount. But if I use less than 4 hours of time, then the red plan is better. And if I use more than 4 hours of time, then the blue plan is cheaper. Here's another situation. This might be the path of like a ball that's thrown up in the air. So this is time and this is height. So it starts 5 feet in the air, it goes up to 9 feet and comes back down to the ground. And I might want to know at what time is this thing when is it 8 feet in the air? So I'm looking for the intersection of these two lines because this is the 8-foot mark. So these are two places where 8 is the y value, and we don't know what the x value is. So we can use our math for that. We can take our other equation, which is y equals 8, and one technique for systems of equations is what's called the substitution method. that's where you can take the y from this equation and replace it with the 8 from that equation. And we get this 8 equals negative x squared plus 4x plus 5. You can watch the video on quadratic equations. It's about 2 videos ago. I like to divide everything through by, or multiply both sides if you want, by -1. And then of all the methods, this one, factors, or you could use, if you watch that video, completing the square or quadratic formula. So x plus 1 is 0. That's the only way this times this can be 0. Or x plus 3 equals 0. Oh, I see I have a small mistake here, which is this plus means that this is plus, means that this is minus. It means that this thing factors different than I thought. It's going to be -1 and -3. So either x minus 1 is 0 or x minus 3 is 0, which makes x equals 1 is one of the solutions to this equation, but it's also one of the solutions to this equation. And you can see here that those are the points. So what I'm getting at in this video is that graphs can be important to find, like their intersections. We can use, we could also use the intersections to find the solution to the equation. In other words, if I had this equation up here, this one, 8 equals negative x squared plus 4x plus 5. If I just want like an approximate solution, one thing that you can do is actually work backwards and graph the two sides of the equation separately. And you see people do this with a graphing calculator a lot nowadays. So you can use algebra equation to find the intersections, or you can use the intersections. If you can draw this, if you could draw these two curves, you can then just look and see what are the x coordinates of the intersection points, and they appear to be 1 and 3, which is the answer to which are the two answers to this equation. So there's this sort of give and take between algebra equations and graphs. And the graphs could give us insight into the algebra equations, and the algebra equations could give us insight into the graphs. Way later, after the scope of these videos I'm making in advanced math, like calculus, we study these curves a lot, and there's a lot of this graphing and using algebra to find things out about these curves. Those curves could have real-world implications. They could be like the motion of an object, and then it's related to physics, or they could just be could be things about money and things sold and how much profit's made, or it could just be math, just for math. You know, this parabola and this line, you know, and where do they intersect? So that's all. I just wanted to finish up graphing because I didn't mention that in the last video about some of these applications, putting together the systems of equations, the two equations, with the graphing of two curves and seeing their intersection points, an important concept in algebra.